The lesson that this video covers is actually the second of two worksheets that are involved with this fourth lesson that you see in the big pictures. So this is what we're actually going to be covering this day. If you look at scope and sequence for this lesson, the actual lesson is called Data and Modeling Trigonometric Functions, and you see that this is the one we're actually going to be covering, called Linking Trig and Stats. Now this scope and sequence is very important to look at because, especially down in the teacher notes, they give you some good information, and also in the presentation strategies to help you break up the days and what problems to discuss and how to present them to the students. Another thing that I like to point out are the technology tips, especially at the end of the scope and sequence, to help you with entering in all the information to your calculator and working those problems. So let's look at this lesson called Linking Trig and Stats. And it starts off with this problem about the days of the year and the percentage of the moon showing. And the very first question asks us to create a scatter plot of the data below in this table. To do that, we're going to use our graphing calculators. And so let's go to those right now. Now, to enter in the information into our calculator, we want to go to the Stat key, press the Stat key, and then hit Edit. You can either hit Enter or 1 for Edit, and then you can enter in the information. Now, in the first column, that's where we're going to put in the days of the year. So that's where you put in the 2, 10, 18, and so on. If you need to clear a column, go up and highlight L1 or L2, then clear and enter. Then in the second column, that's where you're going to enter in the percentage of the moon showing. Now, once you get those columns filled out, we're ready to graph it. But first, before we graph it, to figure out our scatter plot, we have to actually turn our stat plot on in the calculator. To do that, you hit second, y equals, and hit enter on plot 1, and then you can turn it on. You want to make sure it's on this first type, which is the scatter plot. You want to make sure your X list comes from L1 and your Y list comes from L2. Sometimes that gets messed up on particular calculators, so if a student is having problems with these, that may be the culprit right there. We can mark it with an open box, or whichever you prefer, and then if you have the option of the color, you can choose whatever color you like too. Now, in order to get the graph on there in a nice way, the quickest way to do that is hit zoom, and then look down at number 9, stat. You can either arrow down there or actually just type the number 9 and it'll bring it up for you. So we can see from the graph it's going to be some kind of sinusoidal function. And here's the scatter plot. I let my students find the scatter plots in their calculators and not actually have to worry about graphing them on paper. It's up to you and how you would like to do things. If you'd like them to actually have a hard copy visual of it, then have them sketch it real quick. So now that we've created the scatter plot, we can move on to number 2, which asks for the transformations that take place. That's asking for what is the amplitude of this, what is the period, what is the phase shift or the horizontal shift, what is the vertical shift. And you find those by figuring out what your A, B, C, and D are, and then how those manipulate those particular characteristics of the graph. Once you're done listing those transformations, in number 3, they want us to write the best fitting sinusoidal curve. Now, you can do this by using a sine function or a cosine function, and I typically have my students do both. And I actually have them do 2 different cosine functions as well as the sine function, because depending on the starting point, you can have a cosine function that starts at the minimum point and a cosine function that starts at a maximum point. I help my students out with number 4 by showing them a trick with your knuckles to figure out how many days are in a month. Each time you start at your index finger at that knuckle right before it and count the valleys in between your knuckles too. And anytime you land on a knuckle, that month has 31 days. Anytime you're in between your knuckles, that month has less than 30 days. And that helps them add up the number of the days of each month to get to these different days that are being asked about in number 4. Now in number 6, this is why I have them create a sine function in number 3, because now they have to use their calculator to come up with a sinusoidal regression equation and compare it to what they have in number 3. So let's go to the graphing calculator and do that now. Now this was the last thing we saw in our graphing calculator, and we want to get a sinusoidal regression for this. The way you do that is you hit the Stat button, then go over to Calc, and then you can go down this list until you see Sin Reg, which is C. You can really just go down to calculate. Everything should be right, but again, you may want to make sure the X list comes from L1, the Y list comes from L2, and hit Calculate. And then that brings up this window right here, which is your sinusoidal regression and what numbers you need to plug in for the A, B, C, and D. Notice that the format on this one is not the same as it has been, like with the window pane lesson. The BX plus C, the B is not factored out. So that's going to be a little different when they write this down on their paper. So now let's go transfer this back to our work. So now we can write down, according to the calculator, what our equation is going to look like, which is going to be y equals 50.107 sine of 0.213x minus 2.168 plus 49.326. And that would be the equation of the regression line that our regression curve that our calculator gives us. And then it wants us to compare that to number 3. So they are going to have to do some distributing with the B through that parentheses. And then what you'll see is get some decimal approximations of your answers, and that way you'll see how close their equation is to the equation that the calculator gets.